So the first problem I would give you is this system of equations, and I would say, hey, if x equals 3/2 y minus 4, and y equals, you could read it up there, then solve the system. So don't look below, don't look below, thou shalt not look below. You guys just solve that really fast? I don't know how fast it's Is it fast? You guys like each other, this is awesome. Look at like 5 people on 2 chairs up here. This is Minnesota nice. Did I say that right? Was that a good use of Minnesota nice? Yeah, I'm learning. All right. Only been here 48 hours.
Can you read the fraction?
Absolutely. X equals 3/2 y minus 4, and y equals the opposite of 3/2 x plus 7. Anybody in middle school and just notice how I said opposite instead of negative? That's kind of purposeful. That doesn't mean I'm never going to say negative, but I am going to say opposite a lot. Some of you are like, I don't want to solve it, I'll wait. I have no idea what the solution is. I guess I could be solving it too. Okay, tell me this. What are you tempted to do? Why? I've already done the work of isolating variables for you, right? So did you make a decision about which one you used? Yeah, how did you make that decision? Like, did you plug in x down here? Or did you plug in y up here? So, thumbs up if you have an answer, you have a thought why you did it. Nicole, do you have a thought of why you did it?
Yes. I don't know that. Nope. I'm not gonna judge it. I'm just gonna say it.
Excellent.
Thank you. I really just like the y equals, and so I just substituted in for the x because I really.
Wait, so this stuff went in up here.
Nope, other way around.
No.
The x went in.
This stuff went
Yep.
in down here.
Because my head told me that I just need to have the y isolated on this side. So today, that's how my brain wanted to do it.
Okay, excellent. Does anybody have a different reason for choosing one or the other guy in the pink shirt? Or peach shirt?
I substituted the other way.
Okay.
Primarily because
You took this stuff
Yep.
and shoved it up here.
Yep.
Tell me more.
I like to get X first before I get my Y.
Okay, so random reasons. Okay. Does anybody have a reason that is maybe not quite? It's fine. I get it. You wanted y equals, you wanted x equals. Or could there be other math reasons? Yes.
So I substituted the x into
This stuff up here,
Yep.
you threw down here.
Right.
Why?
So typically, when we're like graphing a function, for example, we want it in terms of x. So it's easy for us.
So that kind of feels like what Nicole was saying. Y equals. Then I can throw in a calculator. Like that's a decent mathematical reason. I think we have some other reasons. Yes.
Because if you put the other way, then the 2 goes into the 4 and you don't have a fraction anymore in the second. If you multiply through.
If I throw this stuff, x, down here into this x, then there's something about this 2 and that 4.
That will,
So either way, I'm going to end up with some fractions. But that way, I'm going to end up with fewer fractions. That's interesting. Maybe you didn't see that at the beginning. Maybe now are you going, ooh, that might be something for me to look for next time. That's one of the huge ideas of a problem string, is that you might not think of it, you solve it however you do, and then we share a little bit, you go, ooh, I want my brain to do that next time. Okay. And you like prime your brain to go, ooh, all right, bring it, give me another one. I want to try that. Right? And so then I give you another one. Did anybody have a different mathematical reason than that? Yes?
I substituted the y equation above, so I did not have to distribute a negative sign. I didn't have to deal with the opposite in front of
You didn't want to deal with this negative 3x timesing stuff, multiplied by stuff. So instead you shoved all this up here so that you didn't have to distribute the negative over something. Okay, that's reasonable. Often we try to like help kids. Don't do it that way. You have to distribute the negative. Put it over here, and then because we're just like trying to save them from error. So I would suggest in a classroom we would want to do both and let them come up with that. They'd go, oh, if I did it that way, I wouldn't have to distribute the negative, and I'm not good at that. So maybe I'll try to keep the right. So some nice mathematical reasons. Cool. Then I would have you solve the second one. Has anybody already worked on the second one? Oh, by the way, what was the solution to the first one? 2, 4, is that right? The ordered pair 2, 4? Okay, I'm looking at the time. I'm trying to look at the time. How much time do I have in here? An hour, right?
Yes.
Okay. Okay, let's take a second to solve the second one. This guy right here. Any urges? Maybe before you go too far, you guys are totally thinking substitution for that second one, right? Like that is the first thing on your mind. Anybody wanting to solve for one of those variables? You're laughing. You're like, no, not in a million years. So are you starting to think elimination?
Yeah.
Cool. So somebody eliminate really fast. Now I would be walking around a normal class. I'd be walking around. I'd be looking at what you're doing. I could do that, but then the mic's up here. Don't have a mic in your class. So I'd be walking around looking at what students are doing. I am really using this as a formative assessment time. I'm seeing where my kids are and the kinds of things they're trying. If they're stuck, I'm nudging a little bit with a little tiny Michael Persson hint. You guys know him, Twitter guy? If you're not on Twitter, the only thing I do on Twitter are math people. I don't do anything else. I don't do Facebook either. I don't do social media. I don't have time for that. But I do Twitter. So when Sarah talked about this Twitter blogosphere, that's what MTBOS stands for, by the way. It's Math, Twitter, Blogosphere. Did I even get that right?
Yeah.
I don't even know. But it's this group of people that were like, what if we connected across the world together? So people often will ask me, how do you join that? Oh, you just do. Like you just say, hey, I'm in there. And people go, cool. Like they don't go, no, you're not. I've never seen your application. It's not. It literally is just about, you just sort of start following that hashtag. If you don't know anything about Twitter, ask me later. I'll help you get started. It's a weird world, but there's some really cool stuff going on. I'm totally rambling, so someone will solve that stupid system. What's the solution to the second system? Yes, sir?
Yeah, 2-4.
2-4. So if we were to graph these two systems, where would they all intersect? They would both intersect at 2-4. I'd have 4 lines intersecting at 2-4. In fact, does anybody notice anything else about these two systems? Ooh, we have a noticing right here. Before you answer, does anybody else noticing anything about, oh, now we have more answers. Notice how that pause gave more people a chance to find it before she gives it away. I want more people to look for a connection. Can you give us a hint without giving it away? Ooh, that's hard. Watch what I just did. I just took this kid in the room and I challenged this kid. Don't give me the answer, don't give it away. Give me a hint. That's hard. Hints are hard. You got one yet? Look, I just called you Einstein. Did you catch that? Go ahead.
Moving the equal signs between the
Moving the equal signs. So, abstract hint. I was actually looking for the word obscure, but abstract came out. Does anybody have another hint? I saw several hands. Okay, white sweater.
Can you multiply the first one by something?
That's a hint. A little less obscure, maybe. Go ahead.
You make a table of values.
If I made a table of values, what would happen? I'm not sure anyone in here is actually going to do that, but we could. Go ahead.
Do something with the first system to get rid of fractions.
Something about getting rid of fractions. So if we were to get rid of fractions in the first one, what would happen? So these two systems, I'm not going to take too much time, but I would with kids, right? They're equivalent. They're the same systems. They're not just equivalent, they're the same systems. All I did was just mess around with the fractions. I solved. So then I want to have a conversation with kids. So do you always just want to, you guys were instantly like, oh yeah, we're going to substitute, hands down. There's no elimination happening here. Could we have cleared the fractions and then had this thing that no way you would have substituted, you would have eliminated? So I raised this idea of when do I want to substitute, when do I want to eliminate, and other nice things that came up at the same time. Now, for this presentation, I was actually going to then show you the rest of the string. So you can now look at the rest of it. I free you to look at the rest of it. So then could I ask something like this and then say, so if there's this idea of substitute or eliminate, how are you making your choices? What would you do for this one?
Right.
If what you just did in that conversation we could categorize as mathematizing. What do you think? Is it a little bit different than me going, okay, everybody ready, this is substitution, this is elimination, now do these problems with substitution, do these with elimination. Like how often do we say to kids, let's develop, hey, how many of these did we ever solve? 14,063. And on the 14,062nd, we were like, dude, I think I'm going to substitute when it's like this, and I think I'm going to eliminate when it's like we came up with some ideas in our heads that we look at them and we're like, oh, all right, duh. We have these like sense of when we're going to do stuff. How could we develop that in our kids? I think this might be a way. So if we have some stuff floating around, that's really been my trek these last few years, is for me to listen to people and go, what are the things that you've picked up after the 14th million thing that you've done? Oh yeah, you kind of have this gut feel. Could we develop that gut feel sooner than the 14th million problem? I think we could. And I think it's actually mathematizing.